So let's look at the convergence of sequences and series. Everyone has the handout? Would you close the door for me? Thank you. So last time we did a sequence. What was a sequence? Sequence is a list of numbers, A1, A2, A3, dot, dot, dot. And it is a function from where to where? Set of natural numbers to real numbers, right? And what do we call A1? First term, A2, second term, etc., right? Okay, so let's read this definition. Let's talk about the limit of a sequence. 시작! We say that the real number L is the limit of the sequence AN, written limit n approaches to infinity. AN is L for length epsilon positive. There exists a number n such that blank whenever n bigger than or equal to big N. Okay, so let's fill in these blanks. So if I draw a sequence, I always start at where? Graph of a sequence. Where do we start at? N equal to 1 always. First term, right? So 1, 2, 3, 4, etc. And there is A1, A2, A3, A4. Let's say this is the sequence. So there is a line L, so that, suppose it keeps going up like this. If I look at an epsilon distance, and if I look at this band, after which term all the terms are inside this band? After which term all the terms after that are inside this band? After which term? Is A1 inside this band? No. How about A2? Yes, it's a little bit inside. Okay, so in this case, big N is 2. So A sub n, when n is bigger than or equal to 2, everything is inside this band. Is that right? If I take a lesser epsilon, suppose this is my new epsilon band. Okay, then after which index, everything is inside this band. 1, 2, 3, 4, they are not from 5th, right? Then what is my big N? It is 5, like that. If I can do this for every little epsilon, then we say the sequence AN has the limit, and the limit is L. Okay? So let's fill in the blanks with this information. So we say the limit is L if for what epsilon positive? Any or every, right? For each. So for every epsilon positive, there exists a number n. We should be able to find some n such that whenever the index is bigger than or equal to this big N, what should happen? It should be inside this band, right? That means if I calculate the distance between A sub n and L, that distance should be less than epsilon. Inside this band, meaning if I calculate the distance between AN and L, how do we measure a distance between the two numbers? It's the absolute value of the difference. That should be less than epsilon, right? That's the definition of the limit of a sequence. So there exists a number big N such that, let's fill in these blanks. 시작! Absolute value AN minus L is less than epsilon whenever index is bigger than or equal to big index n. Any question? This is the formal definition of the limit of a sequence. Okay, so for example, does this have a limit? An is n. That's the formula, okay? Does this have a limit? Remember, this L should be a definite number. Where does it go to? It keeps going up. It goes to infinity. So the limit L is not a definite number. So in this case, we say limit n approaches to infinity of an is infinity. Infinity. In your homework, you did this sequence, 1 minus 1, 1 minus 1, right?
Yeah.
Have you seen the homework? So if we look at the graph of this sequence, it will be 1 minus 1, 1 minus 1, like this, right? Does it have a limit? Can I draw a band so that everything after certain number, every sequence, every number is inside this band? Is it ever possible? No. So limit does not exist. The points should get close to a line, y equal to L. So limit n approaches to infinity of a sub n equal to L means, it means a sub n approaches the points. So the points, the line y equal to L as n gets bigger. Any question? So once the limit exists, there is a term. Okay, 시작. If limit n approaches to infinity of an is L, and note that L is a definite number. Is infinity definite number? No, it's not. We say the sequence an is convergent. I told you last time, convergent. 수렴한다. Convergent. Convergent. Next, if the limit doesn't exist, we say the sequence an is divergent. 발산, divergent. So for example, convergent or divergent? What is the first term? 1. Second term? -1. Why is the first term 1? What do I plug in? N equal to 0, right? So when I draw the graph, where do I put the point? At 1 or at 0? At 1, because that's the first term. If I list this out, it will be 1 minus 1, 1 minus 1, right? Dot, dot, dot. So the graph is like this. First term at 1. Oh, I'm sorry. Right, it is -1. Sorry, right. Yes. Yes, sorry. Right. So it is -1, and then when n is 1, it is 1. When n is 2, it is -1, right? Sorry about that. Right. Okay. So this is not the correct graph. So the graph goes like this. Am I right? Okay. Yep. So is there a line where these points get close to? No, it is not. So what do we say about this sequence? Divergent sequence, right? Divergent. How about if I draw the graph, where is my first term? 0 squared is 0. Second term is 1, etc. So 1 comma 0, right? 0, 1, and then 4, and then 9, etc. Right? Okay. So what is the limit of this sequence? Infinity. Is it convergent or divergent? Divergent, because infinity is not a definite number. Any question? Next. 시작. By setting f of n equals to an for all n where f is a continuous function, usual rules for limits of functions applies to the limits of sequences as well. So this is nth term. Okay, so for all n, meaning n starts from 1, 2, etc., right? So we can define a function f of x. F of x meaning x is what variable? X is everything real or some part of real. Maybe it could be only positive numbers, but it's a continuous variable. But in there, we'll put natural numbers n, x equal to n, and we can apply usual rules. For example, we can apply L'Hopital's rule. Remember L'Hopital's rule? Okay, and then we can do limit laws. For example, if limit of a sub n is L as n approaches to infinity, and limit as n approaches to infinity of b sub n is m, so L and m are definite numbers, right? Then what can we say about limit n approaches to infinity of their sum? What is this limit? L plus m, right? So we can apply limit law. Also, if we have a sub n, b sub n, and c sub n, 3 sequences, and for all n, this is true. B sub n is bounded by a sub n and c sub n, and as n approaches to infinity, they go to the same limit. Suppose they also goes to L. They both go to the limit L. Then what can we say about the limit of the one squeezed between? It is also L by what theorem? It's by squeeze theorem, right? So we can use squeeze theorem as well. Fine? Okay, so let's do some examples. 시작. If alpha is positive, then limit n approaches to infinity of 1 over n to the alpha is. What changes? Does alpha change or n change? If alpha is positive, meaning alpha is a given fixed number, alpha does not move. What moves? N changes, n goes to infinity, right? What do we know about n to the alpha if alpha is positive and n gets bigger? It goes to where? N to the alpha. It goes, no, n to the alpha. It goes to infinity. Is that right? Huh? Yeah, no, if alpha is bigger than 0. For example, if alpha is half, what's square root of n? What's the graph? What's square root of x graph? Increases, yeah? X to the alpha, what's the derivative? Alpha x to the alpha minus 1. X is positive, yeah? So this is positive number. This is a positive number, is that right? It's 1 over x to the 1 minus alpha. It's a positive number, so slope increases. So it is increasing. It goes to infinity. So limit of 1 over alpha, where does it go? It goes to 0. Yes, it goes to 0. Is 0 a definite number? Yes. So what can you say about what is convergent? What is convergent? The sequence 1 over n to the alpha. When I don't put any starting number here, you can assume that it starts at 1. Okay? If there is no indication where it starts, you can assume that it starts at 1. So the sequence 1 over n to the alpha is convergent. And what is divergent? 1 over something is convergent, so n to the alpha is divergent. Okay, second example. Again, n is moving thing. It is n approaches to infinity of r to the n. Okay? So what is fixed? R is fixed. Okay? So which r do you have to put in so that the limit exists as n gets bigger? If r is, for example, 2, does 2 to the n converge? How about half to the n? It converges. So, how about minus 1 half to the n? Does it converge? It does not? Does it converge or it doesn't converge? Why does it converge? Even if sign changes, right, they get close to the line y equal to 0. How about r equal to 1? It is 1, 1, 1, 1, 1, 1. So what's the limit? 1. Okay. How about minus 1? R equal to minus 1. Does it converge? It's minus 1 to the n, so it will be minus 1 plus 1 minus 1 plus 1 like this, so it diverges, right? So let's fill in the blanks. If, when is it convergent? If right, so we can put absolute value of r less than 1 or r is 1, right? And when is it divergent? Absolute value of r bigger than 1 or r is minus 1, right? So far so good? What would you do? Limit of quotient. Limit of quotient is quotient of the limits. Is that true? Limit of top and bottom should exist. But in this case, as n approaches to infinity, top goes to infinity, bottom goes to infinity. Infinity over infinity is indeterminate. So you can use L'Hopital's rule. You can treat this as 3x squared minus 2x plus 8 over 5x squared plus 2. Or we can do some algebraic manipulation, that is, factor out the highest term. Factor out the highest term. So this is same thing as equal to, what is the highest term of the top? That is n squared. So we get 3 minus 2 over what? N plus 8 over what? N squared, right? And the bottom, similarly, we get n squared, 5 plus 2 over n squared. Is that right? What can I do with n squared? Why can I cancel them out? Because n is not 0. N is approaching infinity. N is a big number. N is not 0, so I can cancel them out. So the limit of that will be same thing as limit of this. So as n approaches to infinity, where does 2 over n go? 0. This one goes to 0, that one goes to 0, and we get 3 over 5, which is the ratio of the coefficients of the highest powers. Yeah. So we get 3/5. Any question? Okay, how about this one?
One.
Is it 1? E. No, not E. n plus 1 over n minus 1. Where does this thing inside the parentheses, where does it approach? It goes to 1. How about the power here? So we are looking at the limit as n approaches to infinity. It goes to infinity. 1 to infinity. What is that? Is it 1? No, it is indeterminate. When you have f to the g, what was it from calculus 1? What was it?
No,
E to the g ln f. Yep. So we'll have to rewrite that in this form, and then we'll have to use the L'Hopital's rule. Okay, so limit n approaches to infinity of n plus 1 over n minus 1 to the n is limit n approaches to infinity e to the what? N ln quantity n plus 1 over n minus 1 exactly. Fine? Okay, so e to the something is what kind of function? Continuous function. So if limit of that exists, the limit of e to the something is e to the limit of something by the limit law. So we'll see if limit in the side, we'll see if this limit exists. N ln n plus 1 over n minus 1. So far so good? Okay. So as n approaches to infinity, this goes to infinity. Where does this term go to? It goes to 1, right? ln of 1 approaches to where? 0. So what's infinity times 0? Is it 0? No, it depends on how fast each one approaches to the limit. So it is indeterminate. Infinity times limit 0 is indeterminate. So we have to use L'Hopital's rule here. If we had f times g, infinity times 0, then we have to write this in what form? To use L'Hopital's rule, we have to write that as a quotient. Either f over 1 over g or g over 1 over f. It's the same thing, right? Okay. So when I do 1 over g, once I write it in this way, then I have to take the limit of the derivative, quotient of the derivatives, right? So I have to determine, is it better to put 1 over n in the denominator or 1 over ln n plus 1 over n minus 1 in the denominator? Which is more convenient to take the derivative? Number 1, number 2. Number 1 is easier to take the derivative than this, right? So we're going to put this in the denominator. We're going to put that as 1 over g. And keep ln part on the top. So then this becomes is equal to limit n approaches to infinity. We're going to keep ln on the top, but let's simplify this further. What is ln a over b? It is ln a minus ln b, right? So we can write the top one in an equivalent expression that is ln n plus 1 minus ln n minus 1 over, what do we get? We get 1 over n, right? Fine? Any question up to here? So this is 0 over 0. Is that right? So let's do the L'Hopital's rule. So limit n approaches to infinity. N is like my x. So I'm taking the derivative with respect to n. N is like my x. Okay, what's the derivative of the top? Derivative of ln of something is 1 over something times the derivative of the something. Minus derivative of ln of n minus 1 is 1 over n minus 1 over derivative of 1 over n is minus 1 over n squared. So far so good? Okay. Is equal to limit n approaches to infinity. Let's simplify this. Do you agree that this is n squared minus 1? Is it 2 or minus 2? N minus 2 minus. So it is minus 2 over minus 1 over n squared. Agree? When I put them together, yeah, that's n plus 1 times n minus 1. So is equal to n approaches to infinity. When I put that in one fraction, what goes on the top? Equal 2 here, and then n squared times, no. So I get n squared minus 1 and 2, n squared. Fine? Does the limit exist? Yeah, what is it? 2. So is my answer 2?
No.
No, So I know that this limit exists. I know that limit of that exists. And e is a continuous function, so it is e to the limit of an ln part is equal to e squared, right? E is a continuous function. E to the x is a continuous function, so we can put the limit inside. So that's e squared. Any question? So this is an example utilizing L'Hopital's rule. Okay, next. Is this sequence convergent or divergent? Convergent? Why? N factorial. So it is n minus 1, n minus 2, dot, 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 3, 2, 1 over n, right? Yep. So why is it convergent? Denominator is bigger than the numerator, so what's the limit? Why? Why is it 0? If the denominator is bigger than the numerator, should that be 0 always? For example, if I have n minus 1 over n plus 1, right? Denominator is bigger than the numerator, but the limit is 1.
You can divide it.
Pair, okay, sure. So I'm going to look at this as a pair, like this. Okay, good. And then what?
And limit all things equal to what general.
Limit of everything exists. So?
We can use limit law.
To use the limit law, to use the limit law, I have to use it on the finitely many terms.
But the thing was 1, 1, 1, and
1, 1, 1, 1, 1? What's 1, 1, 1, 1, 1?
n over.
N over n is 1, right?
N minus 1 over n is 1. And
Is 1? Why is it 1?
we can take limit.
Right. So, Chair, when you apply the limit law, right, you need to have finitely many terms. But as n approaches to infinity, I will have infinitely many terms. Okay? Sure. Yeah. So, it goes to 1, it's not exactly 1, right? Okay. Yeah. Hint, squeeze theorem. Somebody do squeeze theorem. Squeeze. Give me the top one and the bottom one so that it is squeezed in between and the top and bottom, they both go to 0. I'll give you a hint. N over n is 1, right? N minus 1 over n. Is it bigger than 1 or less than 1? How about n minus 2 over n? Less than 1. Hint. Okay, so I'll give you the left number. Do you agree that these are bigger than or equal to 0? Yeah? Okay. Give me the top one, which will go to 0. Hmm? 1? 1? 1 doesn't go to 0, right? Yep. Anyone? Is that right? Less than 1. When I multiply all this, it will be always less than 1. Yeah, okay. So when I compare this times this and this, which is bigger? 1 over n will be bigger. Right? Because all these are, when I multiply, it is always less than 1. It was easy. Okay. So 1 over what? N. And this goes to, it's a constant sequence. This is 0, 0, 0, 0, 0, 0, etc. This is 1 over n. This is sequence 1 over n. And where does 1 over n go? It goes to 0. So where should this thing go? It must go to 0 by squeeze theorem. Yes. So the limit is 0. So is this convergent or divergent? Convergent, right? Fine? Okay, so note, 시작. Changing the values of a blank number of terms of a sequence does not affect the convergence or divergence of a sequence, nor the blank of a sequence. So I have A1, A2, A3, and it goes forever. Is that right? Suppose I change first 100 terms. Will it affect the convergence or divergence of this sequence? No. Still there are infinitely many terms left over. And I look at the limit of the tail. 꼬리를 보는 거죠, right? I don't look at the beginning. So changing the values of how many number?
Finite.
Finite number. It's a 유한한 number. Finite number of terms, right? Finite. Changing the values of a finite number of terms of a sequence does not affect the convergence or divergence because we only look at the tail of the sequence as n approaches to infinity. And it does not change what of a sequence? If it is convergent, right? Will it change the limit value? In the tail, it approaches to L. So if I change first 100 terms or 1 million terms in the beginning, will it change the limit? No, it does not change the limit value, L, right? So when we talk about sequence, we are only interested in the tail, not in the beginning. Does that make sense? Okay, so nor the what of a sequence? limit, right? Nor the limit of a sequence. Okay, next. If a sub n is less than or equal to a sub n plus 1 less than or equal to b. If I draw the graph of this sequence, this is for all n. Is it going up or coming down? It goes up or constant, right? It's not decreasing. So such a sequence is called non-decreasing. So this part right there is non-decreasing, non-decreasing. And moreover, there is a certain number b which bounds every term from above. So this thing is bounded. So I have a non-decreasing bounded sequence. If I were to draw the graph of this, it will look like that. Agree? It never go over b. This is a number b. What should happen? It should be convergent. They have to get clustered, right? So then a sub n is convergent. It should converge. They should be clustered together. Then a sub n is convergent. Can you give me a similar case for non-increasing sequence? Give me the conditions for non-increasing. So when I compare an and an plus 1, which should be bigger? Non-increasing. So it is going like this. A sub n, And I want it to be convergent, okay? Then, should I put bound up here or down here? I want it to be convergent. Down here. Right, So it should be something like this. B here. Like that. So, I have to put B. I want the condition which guarantees convergence. And these are those. If I have such a thing, then a sub n is convergent. Okay? So, this is a theorem actually. Monotone. Monotone sequence meaning non-decreasing or non-increasing. Monotone. Monotone plus bounded. Then it guarantees what? A monotone bounded sequence is always convergent. It guarantees convergence. Yes? Sure. Come right back. Any question up to here? Yes? AN에 괄호가 있어야 돼요? 오케이. 이렇게 시퀀스를 얘기하는 거니까 okay, right. The sequence is convergent, yes. Fine? Okay. Now let's look at question number 4. 시작. Question. If a ball always bounces back to half its previous height, will it bounce forever? What does it mean by bounce forever and bounce infinitely many times? So bounce forever, bounce infinitely many times, are they the same question or different question? Are they asking the same thing or different things? Infinitely many times or bounce forever. So I have a ball. I have a ball and it was dropped at certain height, let's say S0. So it bounced back to the ground. And then it bounces back to half of its height. Then by the gravity, it will fall to the ground, right? And then bounce back half previous height, fall to the ground like this. Yep. Will it bounce infinitely many times? Yes, it will bounce infinitely many times. There will be infinite of this thing. It never ends. What does bounce forever mean? Forever. Forever. When we say forever, we are talking about time. Forever meaning is the time infinite. That's what it is asking. So this is time. This is height. So there will be infinitely many these bumps. It will bounce infinitely many times. But the total time t, will it be infinity or will it be bounded by a certain number? For example, if I have 1, 1.1, 1.2, 1.3, 1.4, 1.1, 1.11, not this, 1.11, 1.11, 1.11. They are getting bigger, but it doesn't go to infinity, right?
Yes.
Okay, so that's the question. So here, what I'm asking here is not this. It's not this. Yes, it bounced infinitely many times, that is clear, but will it bounce forever? So it's the time t infinity, that's the question. So what we are asking in a sense is the following. Let's read. 시작. If we add infinitely many positive numbers, is the sum infinite? So when we add all these times, these are positive numbers. When I add infinitely many of these times, is the sum, when I add them up, is the sum infinite? That's the question. Okay, so let's explore that. Okay, so from physics, we have this formula. 시작. The height of a ball t seconds after it is dropped from an initial height of S0 feet is S of t is S0 minus 16t squared. So it is minus 1/2 g. And g, because it is done in feet, g is 32 feet per second squared. And by half, dividing by half, we get 16. This is the formula. So, B, 시작. The time that the ball hit ground for the first time, we're going to set it as t0. So, it was dropped at the height S0. And this is the time. This is S. When it hits the ground, that time we'll call it t0. How long does it take according to the formula? How do we calculate this time interval t0? According to that formula, what is it? We have to set this equal to what? 0. Height 0, right? This is the height. So if we set the height 0, we can solve for t. And that's the initial height, S0. Then this is 16t squared is S0. So what's t? Square root of S0 over 4. Time is always positive. So what is the coordinate of this point? That one. So that is square root of S0 over 4. Then it dropped to the ground. So far so good? So T0 is square root of S0 over 4. Okay. Next one. In your handout you have C. Okay, so let's read C together. 시작. After the first bounce, the ball will bounce to a height S1. What will be the next height? S1. S1 is S0 over 2. So it will go up and then it will have to come down. And I want to find that time interval and I'm going to call that T1. Fine? Okay. How do we calculate T1? We calculated this, right? So we can calculate this by putting initial height as S0 over 2. And then because it will be symmetric, we'll multiply by 2. Make sense? So what will be this time? Initial height is S0 over 2. What will be that? It will be square root of S0 over 2 over 4. This is S1, right? So here, this half of that is same like this. So it will be square root of S1 over 4. Is that right? But what's square root of S1? S1 is what? S0 over 2 over 4. Get it? So what's T1? So T1 is twice of that. 2 square root of S0 over 2 over 4. Make sense? Okay. Likewise, we can calculate T2. So it will be half of the previous. And this is T2. Okay. So give me T2. What will be T2? It will be twice of half of the time interval. And it is over 4. So it is square root of S2. S2 is square root of S1 over 2. S1 is nothing but S0 over 2. So it is S0 over 2, right? So it will be square root of S0 over 2 squared. Make sense? Okay, so the total time t is t0 plus t1 plus t2 plus it goes on. So let's plug in. T0 was square root of S0 over 4. T1 was 2 times square root of S0 over 2 over 4. T2 was 2 times square root of S0 over 2 squared over 4 plus dot dot dot. It goes on in this pattern. So it is square root of S0 over 4 plus I can cancel 2 and 4, right? Let's write this as a summation notation. You know this notation, right? Okay. So let's say n. N starts from where? So they all have 2. Agree? They all have square root of S0. Agree? And I can put square root of 2 down here with what power? This is power 1. That's power 2. So I can put 2 times square root of 2 to the power n. And I can start n from where? 1 to infinity. So this is the total time. Make sense? So we are adding infinitely positive numbers. Can we do it? Is it ever possible to add infinitely positive numbers? It's not possible. It's not algebraically possible. Nobody can add infinitely many numbers. Right? So what do we mean by this thing? Right? So that's the question. So let's fill in these blanks first. C, 시작. After the first bounce, the ball will bounce to a height. S1 is what? S0 over 2. D. The ball hits the ground after T1 is square root of S0 over 2 over 4 times 2 seconds. E, 시작. It will then bounce to a height. S2 is square root of S0 over 2 squared. Over? What's S1? S1 is, right, this S1 over 2, which is S0 over 2 squared. And after T2 equal to 2 times square root of S0 over 2 squared over 4 seconds, it hits the ground. Then T is, actually I'm missing T0 here, so please add in T0, which is equal to square root of S0 over 4 plus summation n equal to 1 to infinity square root of S0 over 2 root 2 to the n. Okay. Next, let's read. 시작. Definition. The symbol summation n equal to 1 to infinity an or a1 plus a2 plus a3 plus dot 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 denotes an infinite series, sometimes called infinite sums or simply series. The nth partial sum of this series is the number. Sn is summation I equal to 1 to n ai, the sum of the first n terms of the series. So in our series T, what will be S1? S1 is the sum of first one term of the series. So S1 is T0. First term was T0, right? So how about S2? What's S2? T0 plus T1. Get it? So Sn is what? T0 plus dot 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 plus T sub n minus 1. First n terms, right? Okay. So, what do we mean by the sum of infinitely many numbers? We look at partial sums. S1, comma, S2, comma, S3, comma, etc. Is that a series or sequence? It's a sequence. We know about the limit of sequence. So, if that sequence of partial sums has a limit, then we say the series, the sum of infinitely many numbers, has a limit. Get it? So we look at S1, S2, S3, dot, dot, dot. If this converges to some number S, then we say summation, then we say T, which is T0 plus T1, T2 plus dot, 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 equal to S. That's how we say it. It doesn't mean the actual sum equals S. It only means the partial sums gets close to S. Okay, so let's fill in the blanks here. If the 시작. If the blank converges to a number S, i.e. blank, we say the blank is convergent with some S and write blank. If the blank is divergent, we say the blank is divergent and it is not assigned a value. So with the information that I gave you, what will be the first blank? If the what? If the what converges to a number? AN or SN? SN. So if the sequence is the sequence of partial sums SN converges to a number S, i.e. Sn converges to a number S, how do we write that? How do we write that? Limit n approaches to infinity. Sn, right? Sn equal to S. Yeah. Then we say what is convergent with some S? With some S. With some S. We say this is convergent. The series is convergent with some S. Okay? So we say this series is convergent. We say the series is convergent with some S. So it's the n equal to 1 to infinity a sub n. We say the series is convergent. If the sequence of partial sums converge, then we say the series is convergent. And we give the sum S as the limit of the partial sum. Question? What is series? Series is the sum of numbers. Infinitely many numbers. 급수. 급수. 맞아. Okay. So, and write. And how do we denote that? Then we write sum n equal to 1 to infinity a n is what? S. In such case, we say the sum of these infinitely many numbers is S. If what is divergent? If the sequence of partial sums divergent, this is a sequence. If that limit does not exist, then we say the series is divergent. 이 수열이, 이 partial sums의 수열이 발산하면 급수가 발산한다고 얘기하는 거예요. Okay. So if the sequence of partial sums Sn is divergent, we say the series, that is summation n equal to 1 to infinity an, we say the series is divergent and it is not assigned a value. There's no sum because it is divergent. So let me illustrate this by an example. Number 6, true or false? When I add 1 minus 1, 1 minus 1, 1 minus 1, it will be 0, isn't it? Why not? Why is it false? Yes, it is false. Why is it false? What's S1? 1. What's S2? 1 plus minus 1, which is 0. What's S3? 1. Is that right? Sum of first 3 terms, it is 1. What's S sub 4? 0. So we get 1, 0, 1, 0. This is the sequence of partial sums. Does it have a limit? No, this is divergent. 1, 0, 1, 0. So we say the series is divergent and it is not assigned a value. So there is no value assigned to it. It is divergent. Because the sequence of partial sums diverges. That's for number 6. Number 7, 1 plus half plus third plus fourth plus ... converges. True or false? True? Why is it true? Right. So let's look at this. 1, 2, 3, 4, etc. That's 1 half third. Okay, so when I add the area, what's the area of the first rectangle? 1 times 1, so that's 1. What's the area of the second rectangle? 1 times half, that's half. So 1 plus 1 half plus 1 third plus ... is the sum of the areas of the rectangle, is that right? Okay. And if I look at this function, 1 over x. So it's the improper integral 1 to infinity 1 over x dx. Area under that, which is this part right there. When I compare number 1 with number 2, which is bigger? Area under this curve or the sum of the rectangles, which is bigger? Number 1 is bigger, right? So we get this. So from your calculus 1, integral 1 to infinity 1 over x to the p dx. Remember? So recall integral 1 to infinity 1 over x to the p dx. When is this divergent and when is it convergent?
Limit of
When is it convergent? If p is bigger than 1, when is it divergent? If p is less than or equal to 1. So this is the case. This is the case for what p? P equal to 1. Yeah. Or you can calculate this directly. So this is equal to ln is the limit as t approaches to infinity integral 1 to t 1 over x dx, right? So you have to plug in, this is ln absolute value of x, and you plug in 1 to t and then take the limit as t approaches to infinity. Remember? Remember? Yeah. Improper integral. So this is infinity divergent. Okay. So this thing is infinity, and what we are looking for is bigger than or equal to infinity. So that should be infinity. So it is divergent. Get it? So we can compare this. So this is divergent. The name of this series is harmonic series. Remember this, the name of this series is harmonic series, and harmonic series is divergent. Why is it called harmonic? Because it gives you a harmony. If I take this as a frequency 256 Hertz, it gives you the bottom C. It is this C, okay? If you do the half of this length, so the frequency will be twice 552 Hertz, and it gives you high C. Do you see the harmony? Do you hear the harmony here? Good. And if you do third of it, it will give you high G here. Do you hear the harmony? Right. As the ratio changes, it gives you a harmonic sound. So this is called harmonic series, but it is divergent. Okay? So we'll do 8 and 9 next Wednesday.